Okay, we're going to record video on using motion on a slope. There's two types of question that I want to review. One is to do with actually causing motion, and the second one deals with trying to resist motion, what they call remaining in equilibrium or on the point of sliding. They're synonyms that will come through. So let's start with this first question where a particle is going to actually move. Particle mass 4 kilograms. Now, let's add to the diagram they've got and we'll probably review it and change it in a moment. So, particle mass 4 kilograms. So let's put the mass in. So we've got 4g, weight of 4g newtons pushing down. On the plane at 30 degrees. So we need to quickly think, where is there another 30 degrees? Well, the 30 degrees is there between the normal of the plane and the direction of gravity. So that's where the 30 degrees is as well. Do you need to think, where is it as well? This is the hypotenuse of that, so we get a right angle triangle. Straight down, that is the resulting force made of two components. The point B lies at the greatest slope, and all of this is what happens after we've got some acceleration. So I'm going to say it accelerates down the slope. They tell us that the friction is between P and the slope is 0.3, so mu is 0.3. And we need to think about, like, how is the friction going to move? Well, if particle A is released from rest, friction is trying to act against the force, so our friction is going to act that way. It's going to act up the slope. Friction is mu r. Because we get motion, this becomes F equals mu r. And find the speed. So our first point is we've got to actually find the acceleration going through this question. So that we'll draw the mass and the reaction of the particle, and I'm going back to drawing my rectangles. We've got our surface and we've got friction acting this way, which is mu r. Reaction from between the table and the object, the reaction force is always straight up, and our weight is acting on this angle. So the weight is 4g newtons at an angle to the normal of 30 degrees. Okay, so by similar triangles, remember the weight is the hypotenuse of that triangle. So if we're going to resolve this these forces vertically, so I'm going to resolve vertically, so this is now the solution. That diagram is probably worth drawing still anyway. So resolve vertically, and let's say that positive is up. Motion vertically is 0. It's staying in line with the plane. So that's in line with the plane. So it's not being lifted up at all, so there's no motion vertically. Forces acting on it are R and minus W. Now W is an awkward one because we've now got to calculate W. It's on the adjacent side, there's the hypotenuse and there's the opposite. So we get R minus 4g cos of 30 is the adjacent side divided by hypotenuse, or W, force. So our vertical weight is the weight times 4g cos of 30. So R equals 4g cos of 30. You can do that on the calculator. I'm going to use mine. 4 times 4 8 times cos of 30 is 33.95 newtons. I'm recording more places than in an answer, and I'm also going to record this into a memory. So I'm going to store that in memory A. And I've just made a note here for myself. It's often worth storing these values because they can be used sometimes in other parts of the question. Just getting rid of the mess on that 3. So now let's see what's happening horizontally. And we may as well say acceleration is going this way. So resolve horizontally, I'm going to say positive to the left. It doesn't have to be always to the right. Motion, which is ma, is 4 times the acceleration to the left, is equal to the forces acting to the left, so we've got the weight, and it's the weight times sine of the angle, so 4g sine of 30. Acting backwards, oh, we forgot to go and calculate the friction. So let's go. This leads to friction. Motion happens. But let's check friction anyway. F equals 0.3 multiplied by the 33.95. 3 times my memory A is 10.18 newtons. And we can confirm that we're going to get motion by doing 10.18 newtons. Compare that to 4g sine 30, which is 19.6. Awesome. By 4, forgot the 4. So 19.6 newtons. Hence, we've got motion. That implies we've got more motion anyway. So A is equal to 19.6 newtons minus the 10.18. Go back up. And let's store that back in A now. So 19.6 minus the A was 9.42 newtons. So acceleration equals 2.35 meters per second squared to 3 significant figures. Find the speed of the particle at the instant it reaches B. So we need to use that. B, we now know, is 5 meters away. So we're now breaking this into a SUVAC question. Draw the diagram. Where we've got A, B, initial velocity is 0, acceleration at this point is 2.35 meters per second squared. We want to know the velocity at the end, and we know the distance between the two is 5 meters. Go and do a SUVAT. I've just stored that in memory A again. into memory. So suvac quick check. S is 5 meters, U is 0, V is what we want to work out. A is 2.35 meters per second squared. We have no time. So which of our suvac equations is it? Oh yeah, it's the old friend, V squared equals U squared, add on 2AS. And I'd expect to see minimum it being written out as V squared equals 0 squared plus. Do show the 0 to show that you know the initial velocity is nothing. Plus 2 times the acceleration, 2.35, saying positive to the left, multiplied by the distance covered, 5 meters. Multiplied by 2, multiplied by 5, it's 23.53. So V is the square root of 23.54. Is 4.85 meters per second, and I would expect the answer to be probably given to 3 significant figures.